So it says in a class of 40 students, 34 like bananas, 22 like pineapples, 2 dislike both fruits. Okay, so we had bananas here, pineapples here. Okay, 2 people dislike both fruits, so they were out here. Okay, and then we need to find some probabilities. The problem is, at this point, we need to figure out how many are in the intersection, because this whole circle has to be 34 people, and this whole circle has to be 22 people, but if you add those up, we're getting 58 people instead of the 40 that we should. So, ask yourself, how many people were counted twice? 18. Okay? So the intersection, that's going to be your intersection. 18 people. Must like both, because that's how many people got counted twice. So that means how many people like just the bananas? 16. How many people like just pineapples? 4. Okay? So now that we have this, we can start figuring out our probabilities. Okay? So first of all, we said 18 people like both fruits, so the probability that somebody picked randomly will like both fruits is what?
9 over 20.
Okay, 18 over 40, which is 9 over 20. Okay? 9 over 20, or 45% if you want. Okay? Part B, likes at least one fruit. Now, what are we actually finding there? Finding the probability of...
Everyone except those 2 people.
Okay. In our note, what would we put for the notation?
B or P.
Okay, good. B or union P. Okay? We're finding everybody that likes one or the other or both. Okay? So, you're right, it's everyone except for those 2 people, so 38 out of 40.
What's the symbol for not, like if you're going to do like P not D?
P but not?
Not D, like probability of not disliking.
It's the one.
Oh.
Can you write it like that, or do you have to do B union P?
That's a great question, okay? He's saying, how would we write the probability that we like only bananas?
Well,
Okay.
or just probability of not, you don't like things, which, let's say that's
Okay.
Basically one minus.
If it's just not, we're using the complement, so we'd use the notation. If it's we don't like pineapples, we would use P prime.
Okay.
Okay? That prime means not.
Okay.
Okay? So since there are 22 who like pineapples, we would do 40 minus 22, giving us 18, which you can see when you have the Venn diagram.
It's easier.
It's easy to see it. It'd be 18 out of those 40. This, the notation, the people who only like B, I mean, obviously in the Venn diagram, you can see it right there. It's 16 out of 40. But the notation for that, we actually would want to intersect the people who like B with the people who do not like pineapples. Okay?
Okay.
Think about it. We're intersecting all of B with not P. Okay?
18.
Where do those overlap? Okay? They overlap at 16. Okay?
Attention 7th graders, may I have your attention, all 7th graders. Any 7th grade student who has not yet voted in the student government election should come to Ms. Moody's room 216 as soon as possible. Thank you.
Alright, so that's where we left off here. Good questions here, because understanding it in words and understanding the notation, you know, sometimes are two different things, okay? You gotta understand both. Alright? Now, part C. What's the probability that he likes bananas given that they like pineapples? Okay? What's the notation that we're gonna use here? We like bananas given that they like pineapple.
Intersection of B and P? Or no? It's
Given. What's the notation for given?
Oh.
We remember? Do we have it in our notes?
Yeah, it's the line.
The vertical line, okay? So what's the probability that we like bananas given that that we like pineapples? Okay?
Probability. Oh, so it's 18.
Okay? Now, here's one with a Venn diagram. It's kind of easy because when we say given that we like pineapple, we're limiting ourselves just to these 22 people. Okay? And what we're saying then is, okay, if I'm only dealing with these 22 people, what's the probability that they like bananas? 18 out of 22. Okay? 18 out of 22. Alright, so you notice when you're dealing with conditional probability, you're dealing with a given, you have to consider the fact that we're narrowing our population that we're considering. That's kind of the idea. We're narrowing it down to only dealing with this group of people, the given group of people. Okay? Now, remember the formula that we had though, because the formula can help if you don't recognize that from a Venn diagram, or if you don't have a Venn diagram. The probability of B given P is the probability of both, so here's B intersect P, over the probability of the given. Okay?
So the probability of the intersection.
Yeah, the probability of both over probability of the given. Okay? So what is the probability of both?
9 divided by 20.
Yeah, 9 out of 20. We figured that out in part A. Okay? What's the probability of the given? What's the probability we like pineapple?
22.
22 over 40, which is 11 out of 20. Okay? And if you reduce that, you get 9 over 11. Which happens to be the same thing you would get if you reduce this, 9 over 11. Okay? So whether you use the formula, which sometimes you'll have to use, okay, or whether you use a Venn diagram and just pick out the piece of information that you need, you can get your given conditional probability there. Are there any questions? Okay. Now, here's one similar to the one that Michael was asking about earlier. Okay? We're dealing with a case where we don't like a certain thing. Okay? So we're dealing with a complement idea in this case. So we want the probability that we dislike pineapple. Okay? So what notation would we use for that?
P,
P prime, okay? We don't want them to be in the pineapple circle, given that they like bananas. Okay? What's the probability they don't like pineapple given that they like bananas?
It's not the same.
16.
What?
16 out of 34.
Okay? It's going to be 16 out of 34. Notice the given that we like bananas limits us to this population right here, or this subset of the population. Okay? So there are 34 people in there. How many of those 34 people dislike pineapples? Well, that's these people right here. 16 out of 34. Which is 8 out of 17. Okay? Now again, you could use your formula. What's the probability that we don't like pineapples and we like bananas?
You don't. You 16.
What's the probability of not P intersect B?
16 out of 34.
16 over
40.
40. Okay? 16 out of the 40 people don't like pineapples but do like bananas. Okay? Over the probability of B. What's the probability that someone likes bananas?
34.
34 out of 40. Okay, good. So, you reduce that. The 40s cancel out. 16 over 34 is 8/17. Okay? So again, you can get it either with the Venn diagram or using your formula.
Do you want us to use both approaches on the test, or do you want us to?
No. If you have a Venn diagram and you can just write down the answer, or if you have a table of data that's broken down by category and you can just write down the answer, then go ahead and do it.
Okay, so you're not gonna require us to use different ways to.
Not different ways.
Okay.
No. There will be cases where you'll have to use the formula because you don't have a table or something like that. Okay.
But if you draw the Venn diagram.
Sometimes you can't draw a Venn diagram either. You know, there isn't like a set number of things that you're dealing with. So. Okay. Speaking of not being able to write a Venn diagram, okay, there is another tool that we can use for these conditional probability problems, and that is a tree diagram. Okay, a tree diagram. This problem here is a good example of one where a tree diagram comes in handy. All right, let's read through this and then try to figure this out. Okay. So it says, first of all, the top shelf in a cupboard contains 3 cans of pumpkin soup, 2 cans of chicken soup. The bottom shelf contains 4 cans of pumpkin soup and 1 can of chicken soup. All right. The reason why this is helpful for why a tree diagram is helpful here is because really we have 2 choices that we have to make. Okay? What are our 2 choices that we have to make?
So shelves.
The shelf we're going to use, and then
the type of thing.
yeah, the type of soup that we're going to grab. Okay? So when you have those multiple choices, okay, here's our tree diagram. We're going to pick either the top shelf or the bottom shelf. Okay? And then from there, we're going to pick either the pumpkin soup or the chicken soup. Right? And we have that choice regardless of which shelf we picked originally. Okay? So, does everyone understand how this tree diagram is going to be set up? Okay. Now, let's look at the second paragraph here. It says Lucas is twice as likely to take a can from the bottom shelf as he is from the top shelf. So it's saying twice as likely. So what are the probabilities here?
Like 75. Oh,
If he's twice as likely to choose the bottom shelf as he is to choose the top shelf,
third.
what? We have to use thirds, right? Because listen, right? The probability he picks the top shelf plus double that, giving us our probability he picks the bottom shelf, has to add up to 100% or 1, right? So here's the probability he picks the top shelf, here's the probability he picks the bottom shelf. Those have to add up to 1. So what's the probability he picks the top shelf?
2/3. Or about 1/3.
The top is one third. The bottom is
2/3.
2/3. Okay? He's twice as likely to pick off the bottom shelf as he is the top shelf. Okay? Because as you reach up, you go for the bottom shelf. You know, because it's easier
Yeah,
to reach.
is that just because of like the height of it?
Yeah, maybe that's his height. You know, he's twice as likely because of his height to, if he knows the same stuff is on the two different shelves,
He'll get the shorter.
you know, he'll just go for what's more convenient. Okay. All right, so there we have some of our probabilities filled in. Now let's look at the rest of our probabilities from that first paragraph again. It says the top shelf contains 3 cans of pumpkin soup and 2 cans of chicken soup. So what's the probability that if he picks one of those cans at random, he's going to pick pumpkin?
Sweet.
Yeah, 3 out of the 5 cans is pumpkin, right? So assuming he's not looking and just pulls one at random, he's got a 3 in 5 chance of picking a pumpkin. Okay? So then what's the probability he picks a chicken soup? 2 out of 5. Okay? Now next, the bottom shelf. The bottom shelf has 4 cans of pumpkin and 1 can of chicken. Alright? So what's the probability that he picks pumpkin? 4 out of 5. And chicken is 1 out of 5. Now notice on each of these choices, they should add up to 1. 1/3 and 2/3. 3/5 and 2/5. 4/5 and 1/5. Okay?
Would you multiply them to get the total?
Yes, you would. Okay? So, if I want the probability, and we'll fill this in, even though the question isn't asking for it, it's okay. If I want the probability that I pick the top shelf and pumpkin, I'm going to multiply. So I get 1/5. 1 times 3 over 3 times 5. So the probability of the top shelf and pumpkin, okay, is 1/5. Okay, you multiply them. Okay. When we get to here, we're finding the probability that we picked the top shelf and we picked chicken soup. So what's that probability? 2/15. Now, does 1/5 plus 2/15 add up to 1?
No.
No. What is going to add up to 1?
Wow. That's others.
All of them.
Yeah.
Okay? All of them. Okay? So we gotta do the bottom half here too. The bottom, the probability of picking the bottom and pumpkin is
8 out of 15.
good, 8 out of 15. The probability of the bottom and chicken,
2 out of 15.
2 out of 15. Okay? So 1/5 is 3/15. 3 plus 2 is 5, plus 8 is 13, plus 2 more is 15 out of 15. So all of these have to add up to 100%. Okay? So, we've done kind of the challenging part here. Go ahead and try to figure out what your answers would be here. If we picked one can at random, what's the probability it ends up being chicken? And what's the probability that it was taken from the top shelf, given that we know it's chicken? Okay? So we don't see him, he opens the door, he reaches his hand in, we can't tell which shelf he got it off of, but he pulls out a chicken. What's the probability that it was taken from the top shelf? Alright? So go ahead and try those.
이거四种就是哦，别的是
可以色导这个事儿。
What's 4 divided by 15? It's gonna be around 60.
他真的不知道被大家讲的。对的。对的。你第二个就是该打什么的。
0.26.
4 over 15. 怎么可能是大于1的数？肯定是小于1的数。
Oh wait, yeah, it is.
他说我猜测所有的事情是应该第4项。肯定是上面啊，肯定是上面拿到的几率。下面只有一个气的，上面没有其他。
可是上面写的话是这样还是不这样？
那个是总共的。
那个是在你挑到下一个
That's good. 26.6%
对啊，那还是
first
属于
one.
这样。
不是啊，是
因为它有2个机会挑下面，虽然下面只有一个，但是它挑下面的几率高啊，所以还是属于这样。
个问题是只讨论 top 吗？是不讨论下面的？它只讨论这上面的。
不是，它是随机拿了一个问在上面的可能性是多少？
对啊，随机拿了一个上面是哪里的？
不是拿到上面，是他拿了一个资料问在上面的。
哦，拿了一个鸡哦，在上面。哦，鸡。
拿了鸡吧，
I'm trying to figure out how to get
拿
that
了鸡
smoke
吧。
parking back. I was working on some graphics or community.
我觉得就是1/2啊。
对啊，这个是有算出来的答案。
如果按你的复合是正常的。
因为你想它，它选下面可能性会给到选项只有一个，它还有
We
两
don't
个
really
可
put
以
too
选
much
下
time
面，
into
所以
design good
它
questions
上面选上面可能
because
性
it's
不一
they're
样
all。so bad. So you do it to get your grade as fast as you can. Most grades are probably bad.
我觉得大成功
Is it a hard copy?
It's there's not a single piece of hard content in the class. You just got a lot of busy work and you don't want to do any of it.
经典的话，你刚才说的答案可以问游戏，你还比我你充几百块，你还没有把全一口给攒回来，你怎么知道你？
I use it for everything. I'm making artwork for a friend's birthday.
因为你知道吗？
Next iteration.
其实你要攒钱的时候，你要攒钱还不够。
Yeah, it does CAD animations. Anything with graphics or design oriented, you can do it in.
Mr. Hickson, can I go to the bathroom?
It's like a one-stop shop.
二阶，
Most grades usually have to like their programs.
20哪来的那
And
一万？
then
你是不会舍得把你的号给我，
yeah,
然后你就去玩刀塔2了。
并且现在你不可以融合。
All right, so let's take a look here. Should have some idea of an answer at this point. Okay. First of all, we're finding the probability of chicken. Okay. How could we get chicken?
from the top.
Either from the top or the bottom. Okay. So here's the thing. Really what we're finding, there's a lot of notation here, so stay with it. You're finding the probability of the top and getting chicken or the bottom and getting chicken. Does that make sense? Now, what do you know about top and getting chicken and bottom and getting chicken? Those two events are, they're mutually exclusive. Because you can't pick the top and the bottom shelf. You got to pick one or the other. Okay? So, we can then separate that. If it's mutually exclusive, we don't have to worry about any intersection. We're just getting the probability of the top and chicken plus the probability of the bottom and chicken. Alright, so what does that give us?
You get 26.6 repeating percent.
Okay? How'd you get that?
Yeah, it's 4
Yeah.
over 15.
4 over 15. You have 2 15ths plus 2 15ths. So we've got 4 15ths. Okay? 4 15ths. Okay? Are there any questions about part A? Alright, so now part B. We want the probability that it was taken from the top shelf. So the probability of T given that we got a chicken. Okay? So here's one where you can't just look at a Venn diagram and pick out the one little piecey one. You have to use the formula. So it's the probability of both. What's the probability that we got chicken off the top shelf over the probability that we got chicken at all? Okay? What is the probability of T and C? 2/15 over what we just found, right? The probability of getting chicken at all was 4/15. So good. 15s cancel out, and that equals 1/2. Okay, Nick?
I have a question about just like, to me, I tried to do it where I just eliminated like the choices between like chicken and pumpkin. Like I don't know why that doesn't work because that just makes sense logically. Like just looking at it, the first step between top and bottom, since you already know it's chicken. Like I just don't know why that doesn't work. So like I got it was like a 33% chance that it's from the top shelf because I just eliminated the choice between pumpkin and chicken.
Okay, that's only the probability that we picked the top, without regard to what we actually ended up with. The reason why we have to consider this is because we already see the can. It was taken out of the cupboard, he's got a can of chicken in his hand. Alright, so which shelf did it come off of? That's what we're trying to figure out. What's the probability it came off of that top shelf? So basically what we're doing on this part B, Hugh, quit talking. When we're finding the probability of T given C, the given C part is limiting us to look at just these two parts of the whole situation. And then as you look at those two parts, it's okay, what is this? What's the probability that it came from this branch? Okay, so that's the 2/15 out of the total 4/15. Okay, so there is an element to where you can kind of see it. But again, you're keeping in mind that we now we're not looking at the whole population or all of the possibilities. We're just narrowing it down to the times when we actually get a can of chicken. Okay, and I know this is a silly example talking about cans of soup and what shelf they came off of, but the concept here is the same, you know, that you could use this for medical testing, all right? That's kind of a classic example with medical testing. You know, every test that you run, there's the possibility of getting a false positive. You know, you think you have the disease, but you actually don't. Or a false negative. They missed it, and you actually do have the disease. Okay, and when they do medical testing, they do this kind of probability. What's the likelihood, based on our study, that someone's going to get a false positive or a false negative? What's the probability that, given their test came back negative, they actually do have the disease? Okay, or what's the probability that, given that the test came back positive, they actually don't have the disease? And that's where they do research and clinical studies, and they test these things to see if this is a worthwhile test to do.
Why don't they just
Okay.
give us that as a sample problem?
Well,
Because then it's harder to wrap your head around than cans of soup.
yeah, they're just trying to keep it simple. You know, it's kind of like, why did we use dice and cards for a lot of them? It's just simpler to understand, but we can still learn the principles of the probability. So. Alright, so are there any other questions about the conditional probabilities? Okay. Alright, we're doing pretty well.
Are there practice problems?
Okay. Yeah, that's it for the content, what I wanna do, you'll have to access the PDF, or actually, I'll put it up on the screen here for you, but these additional problems, okay, that the other ones you could have done from the homework you could have done last night. These ones we didn't get to this. So if you did them, I want you to revisit those and work with somebody, okay? If you didn't, you can just start on them, alright?
But these were not on the homework.
These aren't in the book, okay? I just added these. These are from a different book. So we're gonna take some time and work on these.